Alright, so today I'm gonna be explaining just a survey of knowledge editing of neural networks, which is covered in this paper in 2023. So deep neural networks are becoming increasingly pervasive in academia and industry, matching and surpassing human performance on a wide variety of fields and related tasks. However, just as humans, even the largest artificial neural networks make mistakes, and once correct predictions can become invalid as the world progresses in time. Augmenting datasets with samples that account for mistakes or up-to-date information has become a common workaround in practical applications. However, the well-known phenomenon of catastrophic forgetting, this is important in continual learning, that we have catastrophic forgetting in different episodes. So that's why we reduce the weight and they reduce the weight between the next episode and the previous one, the L2 norm. So this is also important. So the well-known phenomenon of catastrophic forgetting poses a challenge in achieving precise changes in the implicitly memorized knowledge of neural network parameters, often requiring a full model retraining to achieve desired behaviors. And of course, continual learning is very expensive. Each time you should keep this loss inside your loss, add it to your losses. It's so expensive. But on the other hand, model editing, because you just add some extra patch to your model, so your model grows something like this, and it's very free, because you have frozen the original model. You just added in some new patches, each time a new patch, but you don't lose the stability and locality. Those are performance measures, if you remember, about model editing. So to address this need, knowledge editing is emerging as a novel area of research that aims to enable reliable, data-efficient, and fast changes to a pre-trained target model without affecting model behaviors and previously learned tasks. In this survey, we provide a brief review of this recent artificial intelligence field of research. We first introduced the problem of editing neural networks, formalizing it in a common framework, and differentiate it from more notorious branches of science such as continuous learning. Next, we provide a review of most relevant knowledge editing approaches and datasets proposed so far, grouping works under 4 different families. So they are either about regularization techniques or meta learning techniques, or you go it directly, direct model editing, or it's just an architectural strategy. So you see, the knowledge editing has been proposed as a task of modifying the model based on a set of individual pairs of edits in a non-sequential manner. Successive works extend the problem to batch of edits, sequential individual edits, and a sequential batch of edits. So you have starting model F0 for all of them, but when you give it to knowledge editing, you have a model. But now we have just this batch of edits. Here you have batch of edits. It's not just single sample, it's batch of edits. And then you do it sequentially, and then mixture of all of them. So to introduce the problem of knowledge editing, it is possible to leverage terminology to define a well-posed learning problem. The task of modifying a model based on a set of individual or batch edits pertaining to the same task known by the model either in a sequential or non-sequential manner. So the objective is to update the model's knowledge representation without significantly altering its original behavior or performance over S. So we use the subscript 0 to indicate that this is the starting model. We define an edit pair, and then in its simplest form, given an individual edit example pair, and knowledge editing can be defined like this. So the function takes the input starting model F0 and edit pair, this pair, to produce edit model. If the edited model is such that this holds, then we say that edit was successful. A knowledge editing approach can realize a transformation from F0 to F sub E in different ways. And you see the taxonomy of edits. For example, in equation 2, this one, it has been given for a simplest case we call a single non-successive edits. We only want to change the model for one edit pair. And then the difference between successive individual or batch of edits is that some knowledge editing methodologies can ingest an entire batch and produce the resulting F of F sub E. So successive edits assume to work with this starting model F sub T minus 1 and apply the T's change like this. And after every change, F sub E should not only satisfy this one, but a series of other properties. Like this, reliability, generality. So reliability, we given an edit pair, the edited model should output desired edit. So this is obvious. The generality but says that the edited model should be able to generalize to similar examples to edit pair. We don't want to destroy our generality just because of fixing one edit. And then locality, the edited model should not alter the outputs that are not similar to edit pair. Those are negative samples, we call them. We don't want to influence them. We just want to fix the hard example. And finally, the efficiency. The proposed knowledge editing methodology should aim to achieve efficient editing, characterized by low computing space complexity. So we have some evaluation metrics such as success rate, generalization rate, edit success, and this drawdown that I think is coming from financial trading. So these are knowledge editing methodologies. It's either about regularization techniques. These articles are about regularization techniques, all of them. These articles are about meta-learning and hypernetworks approach, especially recently. And finally, direct model editing that we see, for example, in this reference. And also we have architectural strategies.